We have known for about 100 years that the Andromeda galaxy is getting closer to us, but we don't know if it's coming straight at us or whether it might be a glancing blow or a distant encounter.
We needed to figure out a way to measure the positions of the stars in Andromeda relative to the background galaxies. We took an image in 2002 and another image in 2010 to see how much the position of the stars had shifted over that time. That told us the motion of the galaxy. The farther away things are, the smaller their motions are, and so it's much harder to measure them.
The delta motion of these stars.
We had to identify the stars that belong to Andromeda and the background galaxies, but the telescope's camera has subtle changes in the way it captures images over time. Those changes can mislead us to thinking that there are motions when there are actually not.
It wasn't until we got a camera with the resolution of the Hubble that it was actually possible to measure.
And with this measurement, we've actually been able to show that Andromeda is actually coming straight at us. But it's going to take 4 billion years before the Milky Way and Andromeda will merge. We know that galaxies are colliding around us in the universe. What happens more often is that a big galaxy runs into a smaller galaxy, and the smaller galaxy basically just gets assimilated in the bigger galaxy. The probability that two galaxies run into each other that are about equally massive, that's actually smaller. So that will be the case for our galaxy and the Andromeda galaxy. Galaxies are actually mostly empty space. So if two galaxies actually collide with each other, the stars basically pass right between each other. And the chance of two stars directly hitting each other is really, really small. In all likelihood, our solar system will not be much impacted. This project is a really nice example of how the Hubble Space Telescope, after 22 years in orbit, can still be used to do totally new science.